Okay, so I'm gonna do a quick video to kind of actually do kind of the whole process, maybe really quickly, but most of this too is to show you how to combine two data files into one data file. So again, let's come back to this idea. I'm interested in the evolution of big cats. So I went into Google and did phylogeny of Felidae to see what other research has been done. And so I'm going to go actually to Google Scholar and see what things are here. And there's actually quite a few studies that have been done from phylogeny and evolution of cats. There's this one PDF here that is a really good summary, but it's from a book, so it's not so much as a scientific explanation, but that would probably be a good one to cite and to have in my back pocket. You know, I look at the dates of these things. This one's 1996, so maybe it's a little old. Okay, here's one from 2005. So let me look at this one. Yeah, this looks like a reasonable thing. It's coming from multiple genes, so I know I could get at least 2 genes probably here. I'm just going to show you kind of maybe what I would do. So let's say I take that title, and then I come over to NCBI, where maybe I was trying to search the Popsets for Felidae, but I was getting 519 hits. Well, I don't want to sit and go through 519, and I started to click on the first few, but some of them were population studies, and so it was like all the same thing. Or like this one, I'm like, oh, links. Oh, maybe that one has 96 sequences, but then when I open it up, it's like all linkses. So I don't want to do just a study of just linkses. I want all different species from inside. So let's say that none of these that come up right off the bat look like really good population studies to use. I mean, maybe there is one, right? Like maybe this one would have been good. It's got 43 species. No, but it's all just Panthera. I want one with different species. So another thing I could do is, remember I had this study that looked like it was promising. Well, if I come and I just paste that study in my search tab, given that it's fairly recent, maybe someone put it on the Popset database, and they did, in fact. Now, of course, this wouldn't work for your projects because there's only 12 sequences and 13 sequences, but let's ignore that for now, okay, just for simplicity's sake. And let's say maybe I'll use this. So I can click on this, open it up. So here's those 12. There's the other 12 from the next gene. So one of them's NADH2 and the other one's NADH4. Let's say that I'm going to go with these 2 genes again. So then I could click on the FASTA tab. Actually, I like FASTA text better. And there I have all of these sequences. And I could just copy and then paste this in a text document, right? And now I have my FASTA data set. But I also wanted to remind you that from Mega, we can build an alignment, create a new alignment. It's going to be DNA. And this opens up the Alignment Explorer window for me. And then within here, remember there is this query the GenBank database, which opens up essentially a web browser, but a web browser from Mega, right, from the program Mega. Now, I could go back and do this exact same search that I just did, okay, and then paste back in that same thing, search. So this is doing the exact same thing as just a regular browser, and there's these 3 Popsets, right? So if I click on this and then go, there it is. And then here you can use this button, add to alignment. And notice it adds them all right there. So you could either go from the actual from the website where you just copy and paste into a text document and then load that into Mega, or I think it's just as easy to use the Mega browser and then use that little, once you get to the text view of FASTA sequences, you can just click on the add to alignment button and it'll add them to the alignment. Okay, and so this is the NADH2. So I'm going to, all right, so now that I have this opened up here in Mega, I can align this, and it may be already aligned because this is, I don't know what's on here in the end here. I'm going to get rid of all those sites. That seems weird. If you ever need to chop off sites from the beginning or end, you can just go like that and then edit and delete, and then that deletes things off of the beginning of end. You want to do that with your own alignments if they look a little messy on the beginning or ends, or even if there's regions within the middle that are really gappy and you just want to get rid of those. It's okay to chop things out. You should at least mention that though in your methods that you chopped things out. So it looks like this one's already aligned, so I don't have to align this because this is protein coding sequence. But if I did have to align it, you guys know how to align your data. So you align your data, and then I'm going to save this so export alignment as FASTA format. Now this one I'm going to save on the desktop as Felidae NADH2.fas on the desktop. Save. And then I'm going to come back to building a new alignment, create a new alignment, DNA. Okay, so now I'm building another alignment here, and I'm going to go back to this web page where I was at using the Mega browser, right? And now I'm going to click on, I'm going to go back one more. I'm going to click on the NADH4 subunit. So the first one had 12 sequences, this one has 13. So for sure, at least there's one taxa that's not in the other one. I didn't look at every single taxa, but I think they're pretty congruent where they have the same taxa in both because it's data coming from the same study. But if not, you would just need to make sure that your two data sets, right, are fairly congruent. If you have one or two or three taxa that's in one and not in the other, it's not the end of the world. You'll have some missing data, but it's okay. Okay, and so I've got this, and now I'm going to change this to the FASTA text view, and then I can just add to alignment. And same thing for this one. I think this one is already going to be aligned, so I don't need to align it. And it does have that, I don't know what this extra text is here at the end, but I got to get rid of that. Otherwise that could cause some serious problems when we try to run the analyses. So I'm just going to get rid of all of those, edit, delete again. Okay, and then I can data export alignment, FASTA format. And I'm going to call this one Felidae, oops, spelled that wrong, Felidae NADH4.fas. And save that on my desktop.